Welcome to Maths and Science by IITian channel. In this lecture, I will be discussing about a very good ratio relation where unknown number a and b are there and controlled by a single equation with a condition that a and b are positive integers. Now, can we have infinite solutions or many solutions or some few solutions or a unique solution? We have to find out a square plus b square. That is our aim. We have to find out how many solutions are there. We have to find out whether there are infinite solutions. We should never think that a single equation with two variables will always have infinite solutions. If the condition says that a and b are positive integers, this is a very big limitation on finding a and b. Let us solve the problem. What is given in the question? A plus 3 divided by a minus 3 is equal to 7 by b, and a, b are greater than 0 and positive integers. We have to find what is a square plus b square. If these conditions are met, solution, let us do cross multiplication. A plus 3 into b is equal to a minus 3 into 7. That implies ab plus 3b is equal to 7a minus 3 into 7. That implies let us say we will take out b common in the left hand side, b into a plus 3, that is equal to 7a minus 3 into 7. Let us try b into a plus 3 is equal to 7 into a minus 3. Can we write in this way? A plus 3 into b minus 7. Let us say what happens. A plus 3 into b minus 7 is ab minus 7a plus 3b minus 21. This you see ab minus 7a, 7a if you bring this side like this, when you see ab minus 7a plus 3b minus 21 plus 3b. This is ab minus 7a plus 3b. Here it is plus 21. Here it is minus 21. When we compare these two equations, When we compare this is the result of this one. This is just our imagination. When we compare these two, can we write a plus 3 into b is equal to 7a minus 21, which is going to become ab minus 7a plus 3b plus 21. Then a plus 3 into b minus 7 is equal to ab minus 7a plus 3b minus 21. This can we write it as ab minus 7a plus 3b plus 21 minus 42? Yes, we can write. That is equal to a plus 3 into b minus 7. This implies this is equal to 0, because we have brought everything on the right hand side to the left hand side. Then can we write like this, 0 minus 42? This implies a plus 3. This is done just only to ensure that we want to find the limits of a and b, so that we can find the range under which positive integers are available for a value and b value. A plus 3 into b minus 7 is equal to minus 42. This is the equation ultimately we have got. This is what is derived from this equation. Now, a plus 3 into b minus 7 is equal to minus 42. And a, b greater than 0 and positive integers. Now you tell me, a is a positive integer. That implies a plus 3 should be greater than, positive integer means 1 is a positive integer, should be greater than or equal to 4. Do you agree? B is equal to positive integer, any positive integer that is greater than 1. That means b minus 7 should be greater than or equal to minus 6. Do you agree? Because if you take b as 1, then b minus 7 is minus 6. B as 2, it will be minus 5. That means should be greater than or equal to minus 6. If you take a as 1, that is a plus 3 is 4. If a is equal to, it is 2 plus 3 is equal to 5. That means these are the conditions, very important conditions from the, these are the inequalities or conditions rather. These are the conditions we have derived from this equation. This equation was derived from the previous conditions given. A plus 3 by a minus 3 is equal to 7 by b. Now, these two conditions are to be met for the solution of a and b. In that case, what are the possible values of a plus 3 into b minus 7 should be minus 42. First condition is a plus 3 into b minus 7 should be equal to minus 42. At the same time, b minus 7, a plus 3 will always be positive. This is always positive. B minus 7 can be either positive or negative depending upon value of b. That means value of b is restricted here. On b, it can be either positive or negative. If b is equal to plus 7, it is 0. b is equal to plus 8 means b is greater than or equal to minus 6, b is 1. But however, a plus 3 into b minus 7 should be negative. A plus 3 always positive. Always. Because a is positive integer. b minus 7 should be negative only. Please try to understand why I am telling there are many methods to solve it. I am not going for the shortcuts. It's not about the shortcuts while learning. It's a method how you use your algebraic and your intuition and your power of imagination in mathematics. That develops the concepts in you. It is not about solving this particular equation. Now, a plus 3 is always positive, b minus 7 should be negative. B minus 7 should be negative means b minus 7 should be negative means b minus 7 should be greater than or equal to minus 1. It should be, so b minus 7 should be negative only, and also we will use this also. B minus 7 should be greater than or equal to minus 6. That means the values for which above conditions for b will be valid when b is equal to 1, because b is greater than 0 also, and b is greater than 0, positive integer. It should be integer also. When b is equal to 1, b is equal to 2, b is equal to 3, b is equal to 4, the conditions under which this is possible, that's all we are seeing. We are not finalizing that this is the answer for b. Now, for values for b 1 to 6, the condition is that, or equation is that, b is a positive integer and a plus 3 into b minus 7. A plus 3 into b minus 7 should be equal to minus 42. And we found that b varies from 1 to 6 from the conditions whatever are given to us. For different values of b from 1 to 6, we will find out the value of a and see whether it is a positive integer or not. Because already for positive integers of b we have got the values 1 to 6. For a we will find out for these 1 to 6 values of b, what are the compatible values of a. First is, if b is equal to 1, that implies a plus 3 into 1 minus 7 is equal to minus 42. That implies a plus 3 is equal to minus 42 by minus 6, that is equal to 7. That means a plus 3 is equal to 7 implies a is equal to 7 minus 3, that is equal to 4. The values of a and b are 4 and 1. These are acceptable because both are positive integers and both are satisfying the condition, this one, satisfying the equation. Now, when b is equal to 2, a plus 3 into 2 minus 7 is equal to minus 42. That implies a plus 3 is equal to minus 42 by minus 5, that is equal to 8.4. That is, a is not an integer. A is not an integer. Hence, it is rejected. Because the main condition is a should be a positive integer. Third case, b is equal to 3 implies a plus 3 into 3 minus 7 is equal to minus 42. That implies a plus 3 is equal to minus 42 by minus 4. That is equal to 10.5. A is not an integer. A is not an integer. Hence, it is rejected. Now, when b is equal to 1, 2, 3, we have seen. b is equal to 4. That implies a plus 3 into 4 minus 7 is equal to minus 42. That implies a plus 3 is equal to minus 42 by minus 3. That is equal to 14. That implies a is equal to 14 and a and b pair will be a is equal to 11. A and b pair will be 11 and 4. Acceptable. 11 and 4 is acceptable. First value is acceptable. That is 4 and 1. Now, fifth one, b is equal to 5 implies a plus 3 into b minus 5 minus 7 is equal to minus 42. That implies a plus 3 is equal to minus 42 by minus 2, that is equal to plus 21. That implies a is equal to 18. Values will be 18 and 5. Acceptable. This is acceptable. Now, sixth, last and final value, b is equal to 6 implies a plus 3 into 6 minus 7 is equal to minus 42. That implies a plus 3 is equal to minus 42 by minus 1. That is equal to 42. That implies a is equal to 39. That implies 39, 6 is the pair of numbers. This is acceptable. That means there are 4 values are acceptable out of the 6 values for b. Then the pair of a, b will be acceptable as first one is 4, 1. 4, 1. Second one is 11, 4. Third one is 18, 5. Fourth one is 39, 6. This is not the end of the problem. We have to find out a square plus b square. Then a square plus b square when a is equal to 4 and 1. 4, b is equal to 1 means 4 square plus 1 square, that is equal to 7. First answer. Second, a square plus b square is equal to, for second one, 11 and 4. 11 square plus 4 square. 121 plus 16. That is 137. These things, if people please do it. A square plus b square is equal to 18 square plus 5 square. That is equal to 349. Then fourth one, a square plus b square is equal to 39 square plus 6 square. That is equal to 1557. That means with the given conditions, for the given equation, having two unknowns for a single equation, it has not yielded the infinite solutions, and also out of the 6 possible solutions of B, for both A and B to be positive integers, only 4 values are acceptable for the pair. That means we have to be very meticulous in calculating and finding whether these values of A and B are acceptable or not for the given conditions. It's not only the equation, we have to see the conditions also. And in this type of question, I have given enough of the concepts in my previous to previous one lecture, where if conditions are seen, the number of possibilities are reduced. This is the way, one of the ways I can rather say to solve the problem. If there are many ways, you can find them and you can solve whichever is suitable for you. This is one of the methods I found good for me, and I found it's logically good. And if you have any other solution, welcome. Please do mathematics. Whichever method is suitable for you, this is one of the methods I have explained. Best of luck to everybody. Thank you for listening to me. Do well, score well in your examinations, and see that you understand the concepts rather than only doing the numerals. In each and every numeral, I develop some concepts and give to you. Please try to grasp them. Thank you for listening to me. If you feel there is a value addition to you because of this lecture, please share my videos and also my channel details, and subscribe to my channel Maths and Science by IITian. Thank you for listening to me. Best of luck.